Jackson, go Northgate Eagles. Go Northgate Eagles. So Jackson, listen to our math learning target for today. Our math learning target for today is I can order fractions and decimals to the hundredths. Now, so if you think there's a big difference between decimals and fractions, then just stay where you are. If you think there's no difference, then roll over. Roll over. Okay, sit. Okay, so what you're saying is there's really no difference between fractions and decimals because decimals are just fractions written another way. So remember, the word order means to put in order from least to greatest or greatest to least. But also remember that decimals are just fractions expressed or written a different way. So if I look at the decimal 0.3 and the fraction 3/10, another way to say 0.3 is 3/10. So 0.3 equals 3/10. Now I could say what I just said, that 0.3 equals 3/10. I could also say that 0.3 and 3/10 are equivalent. That equal sign also means the same, so I could say 0.3 is the same as 3/10. Or I could just simply say that 0.3 is 3/10. So just a little bit of review. Here I have three decimals written: 0.3, 0.12, and 0.08. Our first step is to express them as fractions, and since we're going to the hundredths place, it's either going to be a fraction with a denominator of 10 or a fraction with a denominator of 100. And what we did last time is if we had a decimal that was equivalent to a fraction with a denominator of 10, then we expressed it as a fraction with a denominator of 100, and then back as a decimal. So without putting them in order yet, but just expressing each decimal as its fraction equivalent, 0.3 is 3/10. And then remember, because our other decimals are going to be expressed as fractions with denominators of 100, we can take 3/10, multiply it by 10/10, and find the equivalent fraction 30 hundredths. So 3/10 is 30 hundredths. 0.3 equals 3/10, which equals 30 hundredths. 0.12 or 0.12 is the same thing, or is equivalent to 12 100ths, the fraction 12 100ths. And the decimal 0.08, that 8's in the hundredths place, so it's equivalent to the fraction 8 hundredths. Now in a second I want you to pause the video and think about if we put these fractions in order from least to greatest, which one would be the least, which one would be in the middle, and which one would be the greatest. And then I want you to put them in that order. So pause the video, put them in the correct order from least to greatest, separated by commas. So putting those fractions in order from least to greatest, hopefully you reasoned that 8 hundredths should go first, because when you have 8 parts of a whole that's been divided into 100 parts, that's less than 12 parts of the same whole that was divided into 100 equal parts. And remember, those 100 equal parts are the same size, which is less than 30 of those same sized equal 100 parts. So putting those fractions in order from least to greatest, we have 8 hundredths is the least, 12 hundredths in the middle, and 30 hundredths is the greatest. Now, let's express those fractions as their equivalent decimals, the original decimals that we started with, but putting them in order. Let's express those fractions as the original decimals that we started with, and we can put them in order. So 8 hundredths was the same as 0.08, and so I'm going to write 0.08 under 800. And 12 hundredths was equivalent to 0.12, so I'm going to write 0.12 under 12 hundredths. And 30 hundredths was equivalent to 3/10, which was equivalent to 0.3, so I'm going to write 0.3 under 30 hundredths. So now we've taken those original decimals that we started with, expressed them as their equivalent fractions, put those fractions in order from least to greatest, and then put the original decimals in order from least to greatest. So what if I wanted to compare 4/10 and 0.3? Well, the first thing I'd ask myself is, do I want to express 4/10 as a decimal, or do I want to express 0.3 as a fraction? I think I'm going to go ahead and express 0.3 as a fraction. So think about what's the equivalent fraction to 0.3. And if you said 3/10, that's correct. And so now we can pretty easily compare them because 4/10 and 3/10 actually have the same denominator. So for this example, we don't need to express either fraction as a fraction with a denominator of 100. They both represent a whole broken into 10 equal parts, and 4 parts of that whole is greater than 3 parts of that whole. So 4/10 is greater than 3/10, therefore 4/10 is greater than 0.3. And I think I'm going to stick with that same strategy for this example. So I want to know if 9 hundredths is less than, equal to, or greater than 0.01. So let's express 0.01 as a fraction. And I'm wondering what the fraction would be and what the numerator and denominator would be. So 0.01 is equivalent to 1/100th. And so 9 hundredths compared to 1/100th, they both have denominators of 100, so they both represent wholes broken into 100 equal parts. And 9 of those equal parts is going to be greater than 1 of those equal parts. So 9 hundredths is greater than 1/100th, and therefore 9 hundredths is greater than 0.01. So next, let's look at 0.08 and 1/10, and we're going to compare those two. We're going to compare the decimal 0.08 to the fraction 1/10. What do you think the first step is? That's right, it's to write 0.08 as a fraction. What would that fraction be? That's right, the fraction would be 8 hundredths, because the digit 8 in 0.08 is in the hundredths place. There's a 0 in the tenths place and a 0 in the ones place. So comparing 8 hundredths and 1/10, one thing I noticed is they don't have the same denominator. And so which one am I going to express with a different denominator? If you said 1/10, you're right. We're going to express 1/10 as a fraction with a denominator of 100. And when I do that, I see that 1/10 is the same thing as 10 hundredths. All we did is break the numerator and denominator into 10 times more parts. So we multiplied the numerator by 10 and the denominator by 10, therefore broke them into 10 times more parts. And then we got the equivalent fraction, 10 hundredths. So now we can compare 8 hundredths and 10 hundredths pretty easily. 8 hundredths, so 8 hundredths is less than 10 hundredths because 8 pieces of a whole broken into 100 equal parts is less than 10 pieces of a whole, actually 10 pieces of the same whole, broken into the same sized 100 equal parts. And since 8 hundredths is less than 10 hundredths, and 8 hundredths and 0.08 are equivalent, and 10 hundredths and 1/10 are equivalent, that means that 0.08 is less than 1/10. 0.08 is less than 1/10. So why don't you try doing something similar? I'd like you to try to compare the decimal 0.01 and the fraction 2/10. Don't forget your first step will be to express 0.01 as a fraction. And then if they don't have the same denominator, you're going to want to express both fractions with the same denominator. Go ahead, pause the video and try it. Okay, welcome back. So hopefully you expressed 0.01 as 1/100th, and hopefully you expressed 2/10 as a fraction with a denominator of 100, so hopefully you multiplied it by 10/10 and got 20/100ths, and then compared 1/100th and 20/100ths and realized that 1/100th is less than 20/100ths. Since 1/100th is less than 20/100ths and 1/100th is 0.01 and 20/100ths is 2/10, which is 2/10, then since 1/100th is less than 20/100ths, then 0.01 is less than 2/10. Okay, I think as you've seen when we compared and then ordered or put in order decimals, that comparing two numbers isn't really very different than putting them in order. In both situations, we're reasoning or thinking about their size, and in both situations, we're either just saying that one's less than, equal to, or greater than, or we're putting them in an order that shows the same thing. So let's look at what we have here. We have three numbers. We have a decimal 0.09, we have 30/100ths, and we have 5/10ths. And just think about it for a second. Pause the video and think about it. What would be your first step? So what I notice is we have a fraction that already has a denominator of 100, 30/100ths. We have a decimal that when we express it as a fraction already has a denominator of 100 because the 9 is in the hundredths place, so 9/100ths. And then we have another fraction and it has a denominator of 10, so we're going to want to express that as a fraction with a denominator of 100. And just think about how you would do those things. So hopefully what you did is you wrote 0.09 as 9/100ths. You kept 30/100ths just like it was because we really don't need to do anything to it to compare it to the other numbers. And then hopefully you expressed 5/10ths as a fraction with a denominator of 100. So 5/10ths times 10/10ths equals 50/100ths. Because we multiplied 5/10ths by the same numerator and denominator, that means that 50/100ths is an equivalent fraction, so 5/10ths is the same as 50/100ths. And now you guessed right. I'm going to ask you to think about how we could put these numbers in order. And this time I think we're going to go greatest to least. So when we look at the three fractions that we wrote, 9/100ths, 30/100ths, and 50/100ths, if we're going greatest to least, the greatest is 50/100ths. So I'm going to write that. Then the next one in the middle is 30/100ths, and the least is 9/100ths. So if you put those fractions in order from greatest to least, it should look like this, separated by commas. So greatest to least, we have 50/100ths, 30/100ths, 9/100ths. Now some people, I think the biggest mistake that I saw last time was that some people would just leave it like that. But what we really want you to do is express them as they were originally expressed. So 50/100ths was originally expressed as 5/10ths. So we want you to express it that way. And 30 hundredths was originally expressed as 30 hundredths, so we could leave that. And 9 hundredths was originally expressed as 0.09. So we want to put the numbers the way they were originally expressed in the same order from greatest to least. So when we put those numbers as they were originally expressed in order from greatest to least, we get 5/10 as the greatest, which is the same as 50 hundredths. We get 30 hundredths in the middle, and we get 0.09 as the least because it's equivalent to 9 hundredths. So for your guided practice, I'd like you to put these numbers in order from greatest to least: 4/10, 0.07, and 20 hundredths, using the same strategies we've just used. So go ahead and pause the video and then we'll come back, we'll work through it, and then I'll get you your exit ticket. So pause the video and work through this. So when we put these numbers in order from greatest to least, we're going to remember that they're going to need to have common denominators so that we can compare them. And so these two numbers are already either expressed or can easily be expressed as fractions with denominators of 100. 20 hundredths already is, and 0.07 is 7 hundredths. So then let's look at 4/10. We're going to want to express it as a fraction with a denominator of 100, and just like we've done before, we take 4/10, multiply it by 10/10, and we get the equivalent fraction of 40 hundredths. Now we can put them in order from, again, greatest to least. And when we put them in order from greatest to least, we get 40 hundredths as the greatest, 20 hundredths in the middle, and 7 hundredths is the least. And then, like always, we want to express them as we originally expressed them. So 4/10 is the greatest, comma, 20 hundredths in the middle, comma, and 0.07 as the least. So for your exit ticket, I'd like you to put these numbers in order from greatest to least, using the same strategies we've already used: 30 hundredths, 0.09, and 0.2. Remember, our learning target today was I can order fractions and decimals to the thousandths.